All right, this is section 6.3, non-standard normals, and we'll see how we can get through this. All right, what's it mean to be a non-standard normal? Well, mean is not going to be zero, and the standard deviation is not one or both. In all our problems, either one's going to hold true. To be quite honest, there's not many data sets in the real world that the mean just happens to be zero and the standard deviation happens to be one. But we start out that way because when you have a 0 and 1 for the mean and the standard deviation, your z and your x score are synonymous. So when you look up a value, your x score is your z score. You use your table and off you go. But that's not going to be the case. To be quite honest, you're not going to have to use the table. Reason being is situation we find ourselves in. We're doing this from home, and if I was in class, I'd have plenty of time to work through this on the board. But since we don't, you actually catch a break here, but I still need to go through it. I'm not going to cheapen the course up just because we're doing this online. If anything, I'm going to give you all that and then some. But be aware before you have a nervous breakdown, your calculator is going to set you up. But that doesn't mean you don't have to draw the diagram. You don't have to label it correctly and put the right numbers in. The calculator will do whatever you tell it to do. You put the wrong numbers in, it'll give you the wrong answer. Put the right numbers in, voila, it'll hook you up. All right. If I was doing this pencil and paper, I'd have to take a non-standard normal, use this little formula here, and convert this to a standard normal. All right, standard normal where the mean is zero and the standard deviation is one. Same three situations are going to present themselves. Sometimes you're going to be asked for the area to the left, sometimes the area to the right, and sometimes the area in between. Here's a case where if I was asked, this was the problem, he told me the standard deviation and he told me the mean and this is what he was looking for. I would draw my curve. I would put a vertical line down right down the middle. That's my mean. And then I know if I'm looking for 18, 18 is obviously bigger than 13. I would be marking 18 to the right of 13. I would also know that this area is bigger than zero point 0.5. Half of it's zero point 0.5 and the other half is zero point 0.5 because the area under the whole curve adds up to 1. Obviously, in green here, I see an area that's bigger than half. So that would stop me from making a real bozo answer of zero point 0.3 or zero point 0.4 or something of that nature, right? You need to draw the curve. You're not drawing the curve. I don't know how you're going to do these problems. All right, so that was the area to the left. This is the area to the right. Once again, if I know my mean is 19 and I'm looking for probability of x being bigger than 12, 12 is to the left of 19. This whole area here, I know it's going to be bigger than zero point 0.5. It's bigger than half the curve. All right, that would stop me from making a real careless error. And then, of course, you may be asked to find the area that's in between two values. Here again, if I know my mean is 14, I'm looking for this between 9 and 17. Well, obviously 9 is smaller than 14 and 17 is bigger than 14. So here's the area I'm looking for. This would be my lower bound. This would be my upper bound. All right. But I'm going to walk you through the pencil and paper anyways. Here's our first real example. You get to say a water taxi where the mean weight of people on board are 172. Standard deviation is 29. What's the probability if one man was selected at random? His weight would be less. You need to read less than 174. All right, so I draw my curve. I would mark my mean here if I can draw a vertical line. That's where it comes to go. 172, 174 is bigger than 172. So I already know that the area here is bigger than zero point 0.5. It's more than half. All right, so I would use my formula if I was using pencil and paper and charts. Take my x value, subtract my mean, divide by 29. This is a z-score. I would go to the body of my table, not the body, I'd go to the left-hand column and right-hand column, find 0.07, find the appropriate area for this z-score. All right, so there it is, 0.00 plus 0.07 is 0.07. There's the area. Notice it's bigger than 0.500. We knew that one. The area we were looking for was more than half. All right, so there's the correct answer, right? Using the table. Now, I'm saying that you don't have to. Why? Because our calculator can do this. All right, I'm looking for the area that's associated with this x value is the area to the left. So what do? I would put this in as my lower limit, negative E99, 174. This is my lower, this is my upper. There's my mean, there's my standard deviation. And I'm coming up with an answer. The calculator is telling me that pretty darn close to what I got when I used the chart. All right, 4/10,000ths away. 4/10,000ths, so not bad at all. Two more problems. One, you're looking for the probability of greater than 16.1, and then one that lies between those two values. I'm giving you an example of left, right, and in between. First thing I would do is draw my curve. I would put a vertical line where my mean was 15.2, and I'm interested in values probability of greater than 16.1. All right, so 16.1 is bigger than 15.2. So I know this area here is going to be less than half, 0.500. Suspiciously, when I take this value and change it to a z-score, it just came out to be 1, which is unusual. Now I have to go to my table, find out what area is associated with 16.1. Now be careful because that's going to give me area to the left. I'm looking for the area to the right. All right, so going to the table, 1.0 plus zero point 0, there's an area of 0.8413. Well, I know that's not the answer because this guy is less than half. What this guy, 8.84, that should be a decimal point. This is the area that's associated with this is to the left. You don't want that. You want the area on the other side. All right, so take 1, the area under the curve totally, subtract what you know to be this, and the difference is 0.1587. So using a table, you'd have to find a z-score, and then sometimes you're looking for the area on the other side. No biggie. So let's just cut to the chase. You draw your diagram. You're looking for the probability of a score being bigger than 16.1. So this is your lower limit. It's to the left, going all the way to E99, and then there's your mean, there's your standard deviation. Now here's a case where the calculator returned exactly spot on the correct answer. Didn't need the table. Here's one where if you're using pencil and paper in the table, you'd have to change this to a z-score and that to a z-score. Find the area all the way back, find this area, and then subtract 2, and you would have what you're looking for. Take some time. All right, so taking this score, subtracting the mean, dividing by the standard deviation, there's my z-score. Doing the same thing for 19.7, there's a z-score. Notice it's negative because it's to the left of the mean. 22 becomes 0 when you standardize it. All right, 1.38, 0.96. Going to the table, the area that was associated with 1.38 was 9162 all the way back. The area associated with 19.7 was 1685. Now, what happened is this. You'd have to subtract those two areas. Take the big one, 9162, subtract 0.1685, and we go back here, and you would see that your answer is 0.7477. So that's exact because it was done with the chart, pencil, and paper. It's always going to be exact if you do it this way. So, what if, like you're going to do, is use your calculator? There's your lower limit, there's your upper limit. You know the mean, you know the standard deviation. Provided you do the curve properly, you put 19.7 to the left and 25.3. Now, watch what happens here. This is the reason that I even talk about using pencil and paper. Look at the answer, 0.7465. If I was taking an exam, I would go, oh, gee, look at these two answers. They're both close. Oh, this guy's only 10 away. This guy is 12 away. This is going to be the answer. Well, we just did it pencil and paper and we found out this was the answer. That is the reason that you would have to, the only reason that you would have to turn to z-scores and use your charts. If you had two answers that were very close, and notice, it's not the one that was closest to that was the correct answer, it was the other one. But what I'm saying, again, is that this is the correct answer. I won't give you something like this that's pretty close to it. All right. So you won't have to, but you want to use pencil and paper. I won't make it such that, well, is it B or is it C? I maybe make this point, 2, 5 something, 2, 5, 4, 6, something like that, from far away from this guy here. All right. Helping you out. Helpful hints. I'm not sure how helpful they are. Don't confuse Z scores with areas. Make sure you have the left and right side correct to be able to read. Z scores must be negative whenever they're located to the left half. Probabilities are always positive, they're never negative. We know that. Okay, just like in the case was in 6-2, where I gave you the Z score, which was an X score, and then you found the area. Then I flipped the script, gave you the area, then you gave me the Z score back. But the Z and the X were fine, so you were basically done. Not the case here. We do pencil and paper. All right, here's a case where we're looking for the value that separates the lightest 99.5%. Well, lightest is going to be to your left. Lightest. Heaviest to your right. All right, so 99.5%, moving the decimal point 2 places to the right here. That becomes 0.99, and I'm adding a 0 because the body of the table has 4 places. If this is the lowest 99.5, and then this is the highest 0.5, now this is not going to play anything in my answer or calculating my answer. I just want to make sure that this number and that number added up to 1. All right, so we would have to find in the body of the table the Z score that corresponded to 0.9950. That would give me this value here. But before in 6-2, these two values were synonymous, not the case anymore. All right, so there's still some conversion that needs to be done. Suspiciously, the Z score, this area 0.9950, is one of the ones he actually tells me what the Z score is. All right, he says, hey, the Z score that's associated with that area is 0.2575. Now, obviously, that can't be an X score because if that's 172, how could something to the right of that be only 2.575? Don't make any sense. All right, so you need to do a conversion here. Take the Z score, translate it back to an X score. Let me just kind of flip through these to get to where I want to be. This is the formula you would use. Given a Z score, you wanted to know what X score that was, you would take mu, add to it the Z score times the standard deviation. So it gets to be a little tedious. All right, so doing the conversion, all right, there's my mu, there's my Z score that I found out from the table, there's my mean. Doing the multiplication and addition, we come up with 247, which kind of makes sense. If that's 172, this is to the right of it, 247. Certainly wasn't this guy here. Now, let's see how the calculator would handle this. Once again, now he's telling me 247. All right, so I'm interested in finding this value. All right, what's associated with that value? This area to the left. So I pop that area in. There's the mean. There's the standard deviation. 246.70. Rounded up would be the same thing as the pencil and paper, 247. All right, there's the answer, my pencil and paper, and this is what my calculator gave me. Rounded to the nearest number. So, you wouldn't have to use the table at all. All right, now I'm looking for this X value. I'm looking for that X value. Now, notice that this is my mean here. All right, that's 50%. So I know 0.6 is a little more than the mean. So if this is a 100 right here, this X value is going to be bigger than 100. All right, as we find out the 103. So the area that's associated with this X value is the area to the left, which we know to be 0.6. Pop it in. There's your mean. There's your standard deviation. 103.80. If I were to do a pencil and paper, I would have to go in my table, find out the closest thing to 0.6000. And when he tells me the closest thing in the body of the table was 0.5987, there's the Z score. I put it into this formula. and come up with an answer of 103.8. But guess what? My calculator did it for me. All I did was put in three numbers. So there's a case with the calculator and the pencil and paper. Now here's one where don't fall for the trick. The area that's associated with this score is to the left. If you know that to be zero point 0.8, the area to the left is 1 minus zero point 0.8 or zero point 0.2. You've seen this over and over and over again. It gives you the area that you don't need. You need it to subtract from 1 to find the area that you do need. All right, so I'm going to put in zero point 0.2, not zero point 0.8, because the zero point 0.8 is to the right. This is a left-handed table. All right, or left-handed calculator, I'll say it that way. Area is zero point 0.2. He tells you your mean. He tells you your standard deviation. Hit paste. Hit paste and 87.38. 87.38. Now, if I were doing it pencil and paper, I'd go to the body of the table and I would look for zero point 0.2. The closest thing they told me is 0.2005. There's the z-score. I would plug it into the formula. This would convert that z-score to an x-score of 87.4. But after all that work, my calculator gave it to me. All I had to do is put in three answers. The right three answers. I mean, this is obvious. That's obvious. If you're putting in zero point 0.8, I don't know. If I say the area to the left one more time, I think that kind of wraps it up. No, it's three more. Here you're looking for, I mean, drawing the normal curve is so important. We're looking for the value. We're looking for P45. It separates the bottom from the top, bottom 45% from the top. Here we're looking for P81. It separates the bottom 81 to the top 19. Bottom to the left, top to the right. Here we're looking for P60. Separates the lower 60, the people that you scored better than, from the people, the 40% that did better than you. So I would draw my curve. All right, so I'm looking for this X value, which separates the bottom 45% from the top 55%. The bottom 45 from the top. Bottom you'll find on the left, top to the right. The area that's associated with that is this area to the left. All right, so I pop in 0.4500, 0.45. Pop in, enter the mean and the standard deviation, which is given to you right here. Hit enter, 1,022. Now you see some discrepancy. All right, it's off by about 9/10. But this is not even close. This is 100. That's 21. This guy is 87. This guy is 78. And this guy is 48. Nothing even remotely close. My calculator gave me this. I'd be jumping all over letter D. Not an issue. All right, we want the score that separates the P81, the bottom 81, bottom to the left. Remaining 19% that did better than you. You did better than 81%. The area that's associated with this is to the left. You know because you labeled your bell curve that you drew to start the problem. I wouldn't even read the problem. I draw the bell curve first, and as I'm reading, I would fill in my bell curve. I would start labeling it. All right, so the area is, I put 0.81. I don't need 0.8100. He told me my mean. He told me my standard deviation. Hit enter, 80.1, spot on. There's not even an issue. I don't know how they're coming up with these two answers. It's beyond me. Uh, okay. Yeah. I mean, these two answers don't make any sense at all. And this last one, you're looking for the score that separates the lower 60% from the top 40. You're looking for P60. Notice P60 is to the right of what would have been P50. All right, so the area to the left is 0.60, and then the area to the right is 0.40. Not that I need this, but I just want to make this, match up to what he's telling me here. All right, what I'm trying to do. Top 40, lower 60. So when you fill in your diagram, look back to the problem and see if you've got it labeled properly. Lower will always be to the left. If you got 0.4 here, 0, 0, you've done it wrong. 0.0 is the top. You're not going to find the top to the left. Top is to the right. All right, so there's the area that I'm looking for because the area that's associated with that X score is the area to the left. Once again, I said it left again. 0.60 or zero point 0.6. There's your mean. There's your standard deviation. 212.7. Correct answer, 212.5. I mean, that's somewhat close, but if my calculator gives me this and I see 212.5, I'm not even thinking about 211. I'm looking for 212 with something. If you can't live with that, then, you can always do a pencil and paper, but this is why I show you how to do pencil and paper. If you can't live with that answer being 2/10 away and you're so precise, do a pencil and paper. It'll come out to be exactly 212.5, and I'll show you. This does it here. I'm not sure. No, it doesn't. So happy penciling paper if you can't live with 2/10 being off. I know I could.